Let's say I give you that. That's not.
It's gonna die a little bit. There's still a lot left.
Yeah, well, there's a lot more death to come.
I'm not dead yet.
Yeah, either.
You turn on the little light or is it on?
It is on. Is that better?
Yeah, that's how you know you're hard.
Alright, so this is product rule because you've got, a function with an x in it times another function with an x in it. It's also chain rule. So in the middle of the product rule, so product rule is what?
Second times the derivative of the first plus first times the derivative of the second.
So the first part of product rule is second times derivative of first. Well, when I do the derivative of first, what am I going to have to use? I have to use chain rule. And that's first times derivative of second. And you'll get ones that have chain rule over here too. This one doesn't, but we're working toward that guy. So I'm just combining my two rules. So the second thing is 6x minus 5. The derivative of the first thing, bring down that 3, leave the inside alone, reduce the power by 1, and multiply by what? By 6x, because that's the derivative of the little guy. So this is 2d1 plus plus 1 d2, which thankfully is just 6. I don't have to do anything else. So you're technically done, but the AP test writes these in a pretty specific way. What they would want you to do is look at how many terms do you have in this problem. 6 is too many. This 6x? Derivative of 3x squared plus 4. That's the derivative of Mr. Packer. How many terms do I have? Not so many. There's only 2. Terms are separated by plus signs or minus signs. This is all one term. This is all one term. What they want you to do is look at what chunk is in both terms that you can factor out in front. So there's no 6x minus 5s in this chunk. The 3 and the 6x, I don't really care about those. Those are minor. But this, there's 2 of them there, and there's 3 of them there. So I can take 2 of them and factor them out and put them in front. And so what you're really doing when you factor out is you're dividing both terms by 3x squared plus 4 squared. So in this first term, those cancel, and you're left with all of that other stuff. I'm going to do 3 times 6x and get 18x here. Just save myself a little step there. Plus, and then over here, I still have one of those 3x plus squared plus. I still have one of these things left, right? I had 3, I took 2 and put them in front, so there's still 1 remaining. And that 6 is there. And then they'll want you to distribute those, combine the terms, and that's the answer they're going to look for at the end. And that's what I would want to do. I'll show you why in a second. It's 18 times 6, 36, 72. 108 x squared minus 90x plus 18x squared plus 24. So these problems are just like algebra on steroids. Calculus is not the hard part, I don't think. And you could leave it like this. questions on anything I did there?
How do you know how far to simplify? Because like you could keep simplifying that and square those numbers and then multiply those out.
No, God, no. They want you to find the common chunk, take it out in front, and then get the like terms and simplify inside after that.
That's it. Like you don't ever like
No,
go crazy.
that'd be like a waste of time. Any other questions on this? Where'd you get this from? Why'd you do this? What's a derivative? So the reason they want you to do this is there's very often you're gonna have to find where the derivative equals zero. Like that's gonna be the first step in every problem you do next chapter is take the derivative and set it equal to zero. And in this form, you can set it equal to zero because this is that like zero product property, I think it's called in pre-calc. So you can take that and set it equal to zero, and that and set it equal to zero. That's why they're having you set it up that way. So if you factor it all out, you'd like ruin that actually. All right, let me give you one of those to try. How do you see? There you go. So there's your first step. You want to like checkpoint, see, make sure you get the first part right. And that's the calculus. Like the calculus is done at that point. Now you are basically doing like super algebra to simplify it the way they want to simplify it. Or the way we're going to use it. Which I think eliminates your question. Yeah. I just destroyed your question. But yeah, it would have been 4. You're right. Because if you have 5, you take 1 away. That's not good. That's what the answer is. It's big numbers. I didn't mean to make big numbers. Next time I'll do like 2s and 1s. Really? Yeah.
That's just 7 times 4 plus 32.
He wasn't saying he couldn't do it. Just saying. What? Yeah, 200 is not terrifying, right? A half is terrifying.
Yeah, it is. It is.
That is a fraction. That's, no. Petrifying.
7 or 8 weights, and you're like, what? way harder, but couldn't you write out 4x squared plus 8 with Pascal's triangle and then multiply it all out to get the same answer?
Yes, but if I ask you to set it equal to 0, then you're going to have to factor it again at the end.
Yeah. Well, I was saying that'd be way harder, but I was just.
Yeah, so like you would end up in the same spot if you could do all that correctly, but I certainly would recommend doing that. What?
What's 8 times 35?
All the choices you had here, you chose to ask the teacher that can't speak.
Wait.
What
Well,
do you
here's
choose
the
to-
Here, I
smart.
can figure that one.
8 times
280.
280.
It's same as 4 times 7. So again, I have two terms. This guy over here, and this plus sign is like your divider. And then over here, and you're looking for the chunk that you have in common. So like, I don't really care about the 4. I care about when I have a chunk to a power. So I can take 4 of those 4x squared plus 8 to the 4s, or 4 chunk plus 8 and pull them out in front. If I take 4 of them, there's 1 left there. And that 4 is still there. If I take 4 of them from this term, they're just gone. And then your job would just be to simplify everything inside of that. Diaz, what'd you get when you did all that?
176x squared minus 280x plus
280 plus 32? How many agree with that?
I agree.
Okay. You got what?
I just did that math.
Okay. Question then? And from there down? Is that annoying that I like skipped all that? Like, should I go through that? Or is it okay that I skipped all that? It's okay. Okay. Questions? Alright, next level. Would it be if they both have like a chain rule situation attached? Which problem?
I'll just say how fun it
Is that from Collins Pizza?
Someone brought it in, yeah. Alright, so, second thing, times the derivative of the first thing. For the derivative of the first thing, I need chain rule. So this is the second, this is the D1. Easiest thing in the world to do is forget to multiply by the derivative of Mr. Packer. And then you do all of this work, and you do all the simplifying, and you forgot to take a 2 4 steps ago, and your whole answer is wrong. So be really careful. Plus 1 times D2. For D2, I need chain rule. So this is your 1. This is your D2. Again, I've got 2 terms. I'm going to look at chunks I can pull out of both terms. So how many 4x plus 1s can I pull out? 3. And how many 2x minus 3s? 2. So there's 4 4x plus 1s here and 3 there. So I can take the smaller one. I can take 3. For the 2x minus 3s, I've got 2 there and 3 there. So I can take the smaller one. I can take 2. I'm going to take 4x plus 1 to the third. 2x minus 3 to the second. They're just multiplying. Yep. And then, if I took 3 of the 4x plus 1s, there's only 1 left. If I took 2 of the 2x minus 3s, those are just gone. So I think what I'll do is go down here and say 4x plus 1 times 6, so I'm just taking that 3 and 2, and combining them into 6. Make my life a little bit shorter. I don't want to make my life shorter, that's not what I meant to say. My problem a little bit shorter, but my life a little easier. Plus, so if I took 3 of those from here, the 4x plus 1s are gone. If I took 2 2x minus 3s, there's still 1 of those. take that 4 and 4 and make it 16. And then my job is just to distribute and combine the inside, so 56x minus 42 on the inside. What? I think I got it, don't I? You guys agree? And so again, the reason we're doing this, if I asked you to set this equal to 0, you're basically there. You would just set this piece, and this piece separate equal to 0. We can get our solutions. That's why we're putting it in this form. How many got down to there? What? You're on the right track. Julia, what's the problem?
I'm just trying to see what I did wrong. I got 48x instead of 56. Let's see what I missed on.
Do you have 4x plus 1 times 6?
Yeah.
2x minus 3 times 16?
Yeah.
So 4x times 6 is 24x.
Oh, that's my mistake.
It's like I was second. How's that seem?
Long.
Not that bad, but yeah, they're kind of long. Let me give you one where you're doing it without me starting it for you. Can I take this away? Try that. Then we'll go to the next level.
What's the level of this? 3?
Just have to wait. Can't give away my secrets. There's 2 more levels.
How do you do product rule plus 3?
Wait, it's a date?
Mr. Davis? Do you use product rule? There's like 3.
Yeah,
How do you do that?
one of them gets a derivative and the other 2 stay. Then you rotate which one gets derivative. Does that make sense?
Although it's derivative.
No, you knew what I meant. So. Differentiate. It'd be like A prime B C, B prime C, A B C.
Will we do that?
I've seen it, yeah. Like we won't spend a ton of time on it, but so there's your first step if you want to check that you're on the right path. You got these 2 terms and you're looking to check out any chunks that are common. So the next 2 levels are when we have the negative exponents or fraction exponents. We're all going to be okay, I promise. Not just fraction, negative fraction. Crazy stuff.
So when you have one chain rule, then you can take one of the values. Always there's like one left on either side. Is that always true?
Yeah, because how would you get to that? You subtract the 1 from the power of 8. So that's why there's negative 1 by
Gotcha. And then the same thing with the 2 of them. There's going to both be 2 each one.
It's just because of the way the process works. What is it? it's in the logic. Is that what this is saying? Caleb, is that what it's in the logic? Is that what Rodriguez says?
Stop. Leave. I actually liked you until just now.
I actually like to until just now.
Wow, all the crap I've said to you, and that's what put it over the edge?
Yeah, that does seem.
That's how much I cannot stand physics. It is bad. When you ask a teacher a question and he says figure it out, because they won't let me switch out. I tried.
You didn't like physics. I enjoyed physics. That was fun. I like that.
Could he go through it or not yet?
True.
Someone say hang on. My heart desires going home, getting in my bed.
Those are my heart desires too.
You guys are not welcome in my bed.
That's not where we were
You
going.
were like, me too. Alright. So, I can take 4 of the 2x plus 1s, which would make that become a 1, and make this vanish. I can take 2 of the x to the third minus 2s, which makes this vanish. And then there's 1 left over there. And that kind of pattern is always going to happen, where you can vanish one of them and there's 1 power left of the other. Because that's the way derivatives work. Like, how do we get that in the first place? We subtract 1 from the power. So you're going to always have like 1 more in one term and 1 less in the other term. And then if I start doing simplifying, you guys get 22x squared, 6x minus 20.
Yeah.
Then you got this other stuff on the front. So that's the answer that I'd be looking for. Questions on that one?
Why exactly do we put the brackets?
You don't have to.
you just do it.
It's like
It's like super parentheses.
you don't have to. I think it looks more organized. It makes my brain see it easier, but doesn't mean your brain has to see it that way. Yeah, that's fine. Alright. Let's say 4x plus 3 times 3x minus 2 to the negative third. No fractions yet, just a negative. No, so if you have a choice between product and quotient, choose product. And this is in product form, so we're just going to. So the second thing times the derivative of the first thing, which is just 4. Plus the first thing times the derivative of the second thing. So bring that negative 3 down, leave the 3x minus 2 alone, reduce the power by 1, so negative 4, and then multiply by the derivative of the inside, so 3. And now, because they're negative exponents, it dictates what we do a little bit differently. So instead of factoring out a chunk and putting it in front, I don't want negative exponents in my answer, right? So how do I get rid of them? I'm going to bring them down. So I'm going to write 2 fractions now. 4 over 3x minus 2 to the third, plus, I'm going to say negative 9 times 4x plus 3 on top, because I'm combining like the 3 and the negative 3, you know? And 3x minus 2 to the fourth, the bottom over here. Questions to get to that point? Right? So then I want to add them up. I need a common denominator. You're always going to have like the chunk to the bigger power is your common denominator. So this I'm just going to leave. And what could I multiply this by to turn it into that? Just another one, right? So I'm going to multiply by 3x minus 2. Which now I'll have 4 of them down there. If I do that to the bottom, I got to do it to the top also. So now,
Oh, I see.
if I distribute over here, so now I'll end up with that. So make sure you know where I'm getting that from. Make sure you match. You know if there's questions or issues. So yeah, the calculus isn't the hard part. We got just algebra simplifying stuff that bogs us down. Then I just what?
Will it be always that easy to simplify the denominator? Just like one thing off for as long as they don't always.
Well, so that's the way we take derivatives again, right?
Again.
Because we're
Yeah.
So then you just combine the like terms going across, so negative 24x minus 35. And again, why are we doing that? Because if I asked you to set that equal to 0, top or bottom, you could do it easily. That we're in that form now. That's all we want. Questions on that one anywhere? Can I move it, or is everybody still writing? This one's for you.
Oh, start with fractions or negative fractions.
You're practicing that kind before we move on.
Is that a negative one?
It's supposed to be. I'm just rewriting it. I don't want that smudge to confuse anybody. What's your problem, Fedorov? I hear your little comments over there. Steven, that is Alexis Fedorov. She lives at 20.
Whoa!
I'd be looking for
Okay, I'm not even concerned that like you were telling him her address. I'm just concerned that you had it memorized.
I don't know her address.
Like,
it wasn't
Where you live?
Nice. No one cares.
So you're still in
Yeah.
which district are you in?
I think I'd be going to like Lincoln. Yeah. So.
This is so much fun.
So, I actually think it is. So I don't know if you're being serious or sarcastic.
I think it is a little fun.
Yeah, I kind of
To be
enjoy
honest,
these.
I enjoy
But I'm also a huge nerd. Were you being serious or joking?
a little bit of both. It's been fun so far. I'm just not really looking forward to the fractional exponents. We have to
They're not
play it.
that much different. So there's the first 2 steps. You can check where you're at there. If you got something different, I don't know why. Let me know so I can help you figure it out. Why'd you laugh?
I was stressed because I didn't want to take out the answer, but that was the most step.
Oh, yeah.
So I thought that was the
second derivative of this?
You could, yeah, because now then it's going to be quotient and chain combined. Yeah.
This freaking.
What's wrong? What was that?
Alright, come on, tell me if this is.
That would surprise me. Would have surprised me. Any other questions I'm getting to this point? Alright, then I need another x squared plus 1 over here, which means I need 1 at the top also. While I'm doing that stuff, I'm going to distribute, so negative 16x squared minus 40x all over 5 of these guys on the bottom. 2x squared plus 2, and now I have 5 of these guys on the bottom over there. So now that I have a common denominator, I can add up going straight across, and I'll get negative 14x squared minus 40x plus 2. You guys agree? How many got that?
I made a stupid mistake.
You know you did that.
Wait.
You did for what?
Oh.
You okay?
Oh. Yeah, that's not big.
You good?
Yeah, I'm good.
Any other questions, or need me to pause while you figure it out? Alright, let's do some fraction. First of all, rewrite it, because I don't want that square root sign there. So what power is that to? Is it true that the square root of x squared plus 4 is x plus 2? If the square root of x squared plus 4 is x plus 2, that would mean that the square root of 25 plus 16 is 5 plus 4. See how that logic is the same?
Yeah.
Is that bottom one true?
Yeah.
The square root of 41 is equal to 9, is that true?
Oh, wait, no.
No. So that's like kind of proving this. I did this all the time in high school calculus. I know there's these rules. I don't really necessarily remember what they are, so I just test them. So like in my head in high school calculus, I've been like, I don't know if this is true or not. Some teacher told me probably 15 times, and I can't remember it. So I'm just gonna like test it. So I'm putting in numbers, and I'm seeing if it works out. If it works out, then it's a rule. If it doesn't, then I'm gonna I can't do that. So if you're stuck on something, you know, say like x squared times x to the 5th, some people forget it's not going to be x to the 7th or x to the 10th. Well, take 2 squared times 2 to the 5th, see what number that is, and then try 2 to the 7th and 2 to the 10th. See what, you know, so you can kind of test these rules if you forget what they are. Alright. So you cannot make that x plus 2. It'd be a lot easier if you could, but we can't. That would have been really confusing if I was like, no, just give me the 3. Alright, second thing times the derivative of the first thing. Don't forget that's a chain rule, so you gotta multiply by 3 at the end. Plus first thing times derivative of second thing. So here's where the fraction comes in. It's still just a power, so break it down, reduce by 1, multiply by the derivative of the inside. far?
3x minus 1. Where did you?
Oh. Is that what you're talking about? Yeah. Alright, so now I need to rewrite stuff. Over here, there actually are no negative exponents. So I'm going to just do the 3 times 3 and call that 9. And there's nothing to put on the bottom, so I'm just kind of, there's not much to do in that term. In the term on the right, there's a little more to do. So that 3x minus 1 to the third, does that go on top or bottom? That goes on the top, that's a positive exponent. What do I do with the 1/2? Split it, so the 1 on top and the 2 on the bottom. X squared plus 4 to the negative 1/2. That goes to the bottom, and now it's a positive 1/2. And then I've got that 2x on top also. With me? Yeah.
Before I put it in a fraction form, I combine the 1/2 with the 2x to just make it x.
I was thinking that.
So
you do that.
that's the next thing. You can do that now or later. You could actually just no. You could do it like this and pretend, okay, the denominator needs to have a 2 there, and so therefore you would throw a 2 over here. You could also at this point go, okay, there's a 2 there and a 2 there, so I can cross them out. You could have done that up here too and been like, well, 1/2 times 2x is just x, so I'm just going to put an x down there. Either way you cross them out, I'm just going to end up with an x there. I need a common denominator to add them up, so what do I need to put down here?
X squared plus the square root.
X squared plus 4 to the 1/2. I got to put it on the top also, right? And it's always going to work this way. When I throw another one on the top, I didn't leave myself very much room here. But now, how many are there? How many x squared plus 4s are there on the top? No. 1. When you're multiplying bases, what do you do with the exponents?
Yeah.
You add them up. So I have to the 1/2 times to the 1/2. Like that's square root times square root. So you just end up with like the actual thing. So this times this is just x squared plus 4. Over here. This is even messier than, I don't even think I've seen one this messy on the AP text. But it's okay. It's good for us to go through it. Now I can add going across, right? So on top, I'm just writing down all that crap. And I would say we're not done. Because what could we still do on the top?
The 3x minus 1.
I got a chunk, right? I can take 2 of those and put them out front. It's a heck of a problem here.
Would they accept the previous answer though? If like you did that.
So on a free response, yes. But on a multiple choice, they would keep going, and so you'd have to keep going to figure out how to match it up.
Is this actually something that you would find on multiple choice though?
This seems a bit extreme. I don't think so, but
Other stuff.
yeah, I'm gonna stop there. This is just getting ridiculous.
You know, it's, why is there more that you do? You're like not allowed to have a fraction.
I mean, I could like expand this, combine everything in here.
What happens to
We're
the
done.
x?
We're good.
Nothing, I just forgot about it.
Oh, I did not.
Sorry. Thank you.
And can you put the 3x minus 1 squared totally out front?
Sure.
Okay, that's what I wasn't sure.
So that got a little, kind of spiraled on me there. fraction thing is what I was trying to go for. Does it make sense what I did here with the common denominator for the fraction powers? Okay. So your homework is on Schoology. The printer was still broken this morning, so I didn't